So, starting with the first, that is software engineering. Why it is required? What are the applications? How to design, or how it would helpful for the company growth? Software development life cycle. You can say software development life cycle is again one of the important topics in this subject. Then we'll study different models, requirement analysis, software requirement document, that is nothing but the SRS, which is again one of the important topic. Now, like say for example, if we take one example that we want to make a house, then we have to think about lot of things like cost, planning, designing, etc. Again, say like if we know how to build wall, doesn't mean we would be able to build the whole house by ourselves. It's definitely a team task, right? So starting by gathering requirement about workers, in which area we are going to have our home, then cost estimation, etc. So all these things will be required. Then comes designing, planning, implementing, and so on. So there's all things we would see in this SDLC life cycle. Then another important topic about software engineering is software project management. Because for any project, we first have to decide the estimation. Like if you are making any project, so for that you have to consider many things like line of code, function points, cost estimation, time estimation, risk analysis, its impact. All these things would be covered in this subject. So if we talk about the same, our house example, so you can say that we have to consider and analyze different risks, like how much impact would our house have in case of earthquake or flood, in which area or in which society you are making your house, etc., things. So you have to analyze all these things before starting of your project to save time, money, and to make a good project or a software. And we will also gonna see the famous Kokomo model as a part of this software project management topic. Now the next topic is software design. So in this, we can say that it's not like that if we want to make a house, I have money and I'll approach to builder that make my house. No, it's not like that. It may possible that your builder or your architecture will design your home in his own way, and you have some different. Okay, and you have some different kind of design of your home in your mind. So for that, designing is important. We generally have our you can say 3D design or architecture design, that we want kitchen here or hall here, dining area here, etc. So we make one layout kind of thing, a model kind of thing, we can say. And same way for the software also, we have to first make its design, its layout, so later we can implement that, we can develop that. In this, different kinds of UML diagrams are used that we will study. Then comes coding or implementation part. So like in case of our house example, we can say we finalize everything with our builder, with our architecture designer, like cost, time, worker, everything. And then they start their work. After implementation comes testing. The one of the most important one, say our house is ready. So what we do is we first check that all things are proper according to your requirement and whatever the design that is in your mind. So it may possible that you may call your relatives to see if some things you want to change or enhance, or something color you want to change, or etc. Same way, once the software or say whatever the feature you have developed, you have to check that whether it is working properly or not, as per your project requirement, as per your business requirement. In that, different testing strategies are required, like black box, white box, integration testing, etc. After testing comes maintenance. Say you have tested your software well, you have hand over it to your client, or say you have shifted to your new home in our housing example. So does that mean all your responsibilities are over? No. It said that now the phase is started in which you have to maintain that software on a regular basis. Like in the case of house, you have to clean it. Either you do it by yourself or with the help of house help, but you will maintain your house. In like you require to paint your walls time to time, some plumber work you require, or anything else to solve the problem with your house. Same way, once we deliver our product or deliver our software, it may possible some issues arise from the client side, and so we have to resolve that. We have to fix that. If your client is handling it by himself after delivering that software, then it's fine. But if you both are agreed to develop and maintain your software or your product after its delivery also, then as per your SRS document, you have to take care of your software maintenance. After maintenance, the next topic we would see is quality management, meaning that whatever we are making, it should be ISO certified. Say, for example, we have seen in coffee ads or in case of gold, okay, that is certified things. Same case for our software, the quality should be maintained. Then another thing is reusability. Say I have made a home, I want to use it for next 20 to 30 years, and then I would shift somewhere else. But still, I want to earn some money from that particular house, from that particular investment. So I can turn that into PG. I would gain income from that. So this is called reusability. Same way to reuse software or project is also an one kind of art, you can say. So when you enter into any software organization, all these concepts would be helpful to you in some way in your job. Like whatever your designation is, whether it's software development or tester, web designer, software designer, or anything else, you should have at least basic knowledge of software engineering. Means whenever we are going to develop the project, means here we are not talking about the coding only. Okay, what you are going to do, that is not the only thing, but the project, the way you are going to deliver, that is also the important thing. From starting to ending, all the things that is associated with this software engineering. What are the criteria that has to be followed, and the systematic approach that you are going to use during your software development life cycle, and what are the discipline that you have to follow to create any product. So this is, you call it as a software engineering. So now with this, let's start with our first chapter, that is the introduction to software and software engineering. Are you guys getting me? Okay, good. So first of all, what is software engineering? As you know that it is the combination of two terms, software and engineering. So first, engineering. What is engineering? We all know that it is one kind of, we can say, the process of designing and building something that serves a particular purpose. So whenever we are following some set of procedure to get desired output, it is called engineering. You can say it is an application of science, tools, and methods to find cost-effective solution to our problems. And what is software? So you can say it is basically a program or set of programs containing instructions which produce desired functionalities. So are you getting the difference between software and engineering? It is just that in engineering it consists of some specific procedure, whereas in software it is a collection of programs containing instructions. Also, the software comprises of data structure that enable the program to manipulate your information. So software takes, you can say the software takes some input or data and manipulate the information and gives you the output. And software is embedded in systems of all kinds that we already know nowadays, that it is used in transportation or medical, telecommunication, military, industrial processes, entertainment, office products, etc. The list is, you can say, the almost endless. So software is virtually inescapable in modern work, and as we move into this 21st century, it will become the driver for new advances in everything, and that we already know. So now we can define from this engineering concept and software concept, we can define a software engineering as, like, it encompasses a process, a collection of methods, and an array of tools that allow professionals to build high quality computer software. Basically, it is just a systematic approach in which we aim at developing desired quality software, and this systematic approach not only deals with the development of the software, but it also deals with the maintenance. Maintenance, as we see before, is if we deliver our software once and even after that some changes come, then also we would be able to maintain that software and giving customer the facility to accommodate with those changes. So you can say the IEEE definition of software engineering is something like this, that software engineering is the application of systematic, disciplined, quantifiable approach to development, operation, and maintenance of software, and that is the application of engineering to software. It is just summarizing all the things that we have seen. Now let's come to the evolving of software, or you can say the dual role of software. So whenever we talk about software, it can be categorized into basic categories, two basic categories. The first one can be when software is serving up as a product, or when software is serving the purpose of a product. And the second category can be when the software is serving as a vehicle for delivering the product. Now let's see the difference between these two. So when you can say that when software is working as a product, or to be specific, when it is delivering the functionality of product, at that time it is delivering the computing potential of hardware. It is delivering the computing potential of hardware. Now what do we mean by computing potential? Computing potential means whatever the functionalities are expected from the hardware, it helps means software helps to deliver those functionalities. Say for example, phone. So software inside that would help to deliver the expected functionalities of that phone. Like we have our normal laptop, or if we talk about some PC, then we have the hardware part like keyboard. So the software which is inside the keyboard, it will help that keyboard to provide the functionalities which is expected from that keyboard. Okay, the working of the keyboard. So it will help that. So we can say that when a software that acts as a product, it delivers the computing potential of the hardware, or it enables the hardware to deliver the expected functionalities. Now, second thing, apart from this, when software acts as a product, it also act as information transformer. Now, what is that? So we can say that now transforming the information is a very sole purpose, you can say main purpose of any software, you can see. So when we say that one software that acts as an information transformer, it can basically transform two different kinds of information. One can be a business information and other can be a personal information. So there are the varieties of software which serve different purposes, but any software has to manipulate the information so that the input that it is taking, it can transform the input and give us the desired output. Because the transforming the information is the main purpose of any software. Say for example, you can say salary check generation software. Okay, so what is that? Software that automatically generate salary checks at the end of the month. Or you can say software that counts the employees attendance based on punch out timings registered by that particular employee. Okay, then you can say another example can be software that analyzes the given data stored in the databases, and that software gives the desired output of a query that has been put up to the software, which is nothing but a kind of query retrieval software based on any data which is provided, like stock market data or patient or employee data, whatever. And when we hit the query, we would the software should be able to give the desired output. So you can say that information will be transformed as per the desired functionality of the software. So this is all about when software is working as a product. Now the second role of the software is it will act as a vehicle for delivering a product. So in this case, you can say that the software doesn't deliver a functionality of its own. Rather, it helps Rather, it helps in creation and control of other programs, meaning that whatever the software is there, in this case, it would help other software, or you can say it would help other programs to get implemented, or it would help to provide a runtime environment so that whatever the features or functionalities they want to provide, they can be implemented correctly using that platform. So can you give me any example when you can say the software is working as a vehicle for delivering a product? Yes, anyone? It is very simple, we are using it. Okay, then the most basic example, we can say the operating system, because it provides, the environment to other application programs to run, right? Then anything else? So are you getting the difference between these two, the software working as acts as a product, or software working as a vehicle for delivering a product? These are, you can say, the two dual roles of software. So I'm assuming that you guys are getting me, right? Okay. So now let's come to why software engineering is important. Okay, because we will be studying the entire subject on what is software engineering. So we should know why software engineering is important. right? So we can say to develop software we require a lot of steps and uh, some systematic approach. If we don't follow some systematic approach, then it leads to chaotic situation. So SE, the software engineering, imposes discipline to work and so that our software development process won't become chaotic, right? Then another thing you can say is that it ensures high quality software. Means whatever the business requirement are there, client's requirement or business requirements are there, the final software should satisfy all those requirements. It should satisfy the aim behind development of that particular software. Okay, all the business requirements and clients requirements should be satisfied when we are delivering that product or hand over that product to the client. Also you can say that software engineering helps us to enable to build a complex system or software in a timely manner. So whenever we have, you can say, a huge project, we need to set proper deadlines and milestones of the time taken by each step, and in how much time the software would be able to complete that particular, and in how much time we can able to give that whole software to the customer. So you can say, for example, if we talk about this house example, so in the very first meeting, the customer informed leader that he wants house ready in 1 or 2 years, and he agrees to that and start the work. And after 1 or 2 years, the house is not half completed. So that should not happen. Okay, the project should be completed in a timely manner. Whatever we have, whatever the developer or whatever the things which are decided in the first meeting, or you can say whenever the client has decided to give that product to develop to that particular developer. Now you can say another is reliable software. Okay, that is also one of the quality of software engineering, because software should be secure. Means if you have delivered the software, then it should work for at least its given time or subscription. And if any bugs come in the software, the company is responsible for solving all those bugs, because in software engineering, testing and maintenance are given, so there is no worry of its reliability. Also you can say software engineering would require to achieve scalability, meaning that if I have delivered my product to customer, they like my work and they want to add some features or enhance the product. Okay, so in that case also my software should be capable enough to handle more modules which are coming from the new requirements, you can say, from the client, or to make it more user friendly software. So software engineering will help to manage the dynamic nature of software, you can say. Then again you can say software engineering is used to minimize the software cost. How? So you know that software needs a lot of hard work, and software engineers are highly paid experts. So a lot of manpower is required to develop the software with a large number of codes. But in software engineering, programmers project everything, and all those things that are not required. Okay, uh, all those things are required. Every small planning is required. So the cost of software productions should be decided in the advance only, that uh, what will be the final cost after delivering this product. Okay, so we can minimize those costs by deciding all those what the procedures we are going to use, and how you can minimize the cost using that systematic approach. So that we can say that software engineering is required for cost management, because it is following that systematic approach. We can have the cost estimation of overall software by adding up the cost for each and every phase of this software development life cycle. Like you can say how much manpower and resources would require in development, in testing, in maintenance, etc. So you can, if you know in advance, then you can work on it to make it cost effective. Now, uh, you can, the next is the quality management. So after applying all those things, you can say the better procedure of software development provides a better and quality software product so that you can hand over it to the client. So you can say that the one who is associated with all this software development process should possess some characteristics, some features, like it should have, he or she should have exposure to systematic methods, like familiarity with software engineering principles, which particular method will be the good for that particular software to develop. Then you can say they should have good technical knowledge of the problem domain, whatever the software that you are going to develop. Then good programming abilities is also required. Then communication skills, because the skills comprise and like everything, like oral, written, and interpersonal skills to handle the clients, stakeholders, etc. Then they should have the sound knowledge of fundamentals of computer, and you can say the software engineering science. Then they should have ability to work in a team to develop a huge project, discipline, etc. So all these things would help you ultimately to develop a good quality of software. Now, um, hello. So now from all this, we can say that uh, uh, we can say that what software engineering actually focuses on. So we can say that there are two main points in this software engineering that majorly focuses on. One is the quality, which is the quality while developing a software, and after the quality software has been developed and hand over to the client, the second major focus is on maintainability. So the first quality can be of two types, functional or it can be non-functional. Now, what is the functional and non-functional? So as the name suggests, the functional quality refers to the features, or you can say the functions that are delivered by the software. So we can also say that to what extent we have delivered the correct software from which we are getting the functions that are expected. So this functional quality is nothing but it basically the qualities or qualities of functionalities according to the specifications. Okay, and the specification is just the user requirement that was specified very early in the beginning of the software, and it is the degree to which the correct software has been produced. So this functional quality is nothing but the, you can say, the features or the functions that are to be delivered by the software. Now coming to the non-functional quality. So the non-functional quality basically deals with features other than the functions of a software. Okay, it basically deals with the features other than the functions of a software, like robustness. Okay, the it is also one of the features. Then you can say the reliability. Okay, so those are the features that comes under non-functional quality, which is different from the functionalities of the software that the software is going to provide. So these are not dependent on that particular functionality of the software. but it is, you can say, the non-functional quality measurement and non-functional quality, or you can also call it a non-functional attributes, okay, or the structural attributes. Now, so we can, in general, we can say that the quality is of two types: functional and the non-functional quality. Functional quality is basically focusing on the degree to which the correct software is produced, and it should have all those functionality which is from the business requirement and from the client side. And non-functional quality basically refers to the features other than the functionality of the software. So apart from this quality, software engineering also ensures that after the software has been developed and it is delivered, the software should be maintainable. It means that it is very simple, as the name suggests, that it should be easily enhanced and adapted to changing customers' requirement whenever the new requirements or new changes comes, as we told, as we discussed it above. So these are, you can say, the two main focus areas of software engineering process: quality and maintainability. Okay. Then the next topic is types of software. So you can say that there are various types of software, starting with the system software. So you can say that the software that provides a platform for other softwares to run is nothing but a system software, or we can say they service other programs. So this software basically helps other software to run and provide environment so that they can run. The common example, you can say, the operating system, which provides a platform to several other programs, whether they are application programs or any kind of software, so that the software can run smoothly and perform its task using the services provided by that operating system. Then, other than that, you can say the compiler. It is also one kind of system software. Then, also the device drivers. That is also the example of system software, because they helps to run software of devices and etc. Okay, so that is the system software, which provides a platform for other softwares to run. Now, coming to the second category, which is the application software. Now, what is this application software? So, you can say that the application softwares are developed for a particular purpose, whether to fulfill business need or personal requirement. Okay, so these softwares are developed to fulfill particular requirement, particular purpose. If it is satisfying some particular business need, then we can call them a business software also. It may possible that they solve or they may not solve the particular business need, rather they are developed for some personal computers, personal use, that are used by a normal audience, normal user, and not, it is not used in industry or any kind of business. But so when an application software solve a particular business purpose, we can say that this software act as business software. Okay. So, and you can say the example of this kind of business software can be the payroll software, which is used to calculate the payroll for the employees. And then we can say that enterprise resource management system, or management information system, etc. All those things comes under the business software. That is nothing but to fulfill the business need. Okay. Apart from that, the another domain of application software is personal need, when it is uh, not being developed for satisfying the business need. You can say that it may develop to satisfy some personal requirement when they are developed for the for to satisfy the user requirement, to make the user work easier. Say for example, you can say whenever the software is made to enhance the experience of user, like you can say word processor or PowerPoint presentation, or normal you can say gaming software, so we can refer it to the personal computer software, basically for the personal use, which is developed to make the user life more easier. So you can say the application software can be the business software also, and it may be developed to enhance the user life, or you can say the personal software. So that's all about the application software. Now, the third software is engineering software or scientific software. So, as the name suggests, these are the software which serves some particular scientific problem, or you can say they solve the uh, particular engineering problem. So this software requires some complex kind of calculation, because the complex numerical problems are solved by this software, and they are very number crunching in nature. They would require a lot of calculation, and also you can say they would require a lot of statistics. Okay, so these are the software which solves some particular scientific problem, and that is the reason that they are developed uh, to to solve that particular problem. So you can say the example can be like astronomical software, okay, and other can be the software that can be used for genetic analysis. Okay, so these are the software that require complex calculation, and those complex computation cannot be correctly, or you can say accurately, done by humans, so that are done by this kind of software, which is engineering software or scientific software. Are you getting me? Okay, good. So now coming to the our next category, which is the embedded software. So this software you can say provide us a very limited features or functionalities. They have restricted functionalities. So we can say that the example of this software can be provide us the restricted functionalities are like the microwave oven, you can say, or you can say dashboard displays, like cars dashboard displays, or you can say the plane cockpit control panel, etc. So these are the software that provide us a very limited number of features or functionality, or they would just provide us the restricted functionality, not more and many functionalities. So ultimately saying that the main characteristic of this embedded software is that they have just limited number of functionalities. Now, the next one is the artificial intelligence software. Okay, the famous one. So it just what is that meaning? That it just tries to replicate human intelligence. Complex algorithms are used in these softwares, and they solve the complex problems. You can say that the example of the software can be like Siri, Google Assistant, robotics, then game playing software, you know, because in game playing software, in the sense when the machine has an equal, or even I would say more intelligent approach in playing the game, like if we play chess online, and let's say the computer is your opponent, then all those intelligence is already fed to it, so that it would choose the best possible move to continue in the game. All right, so these are some of the examples of artificial intelligence. And you can say it is somewhat used in Gmail also, because it just filter out which is a spam mail on using some particular words. Okay, then using some face recognition techniques, it is also used in social media platforms. Okay, there are number of examples that you can give in the case of artificial intelligence software, and we are actually using it every day in our life. So now, next one is the web or mobile applications. You can say it is again one broad category of software. Web applications or web software are those that run on the browser, and you can say the example of the software can be online editing softwares or any application that is capable enough to run on the browser and provides its desired functionalities. Okay, and if we talk about the other category, that is the mobile application. So as we know that this mobile application or mobile software are the ones that run on the mobile devices that we already know. And you can say the mobile phones or tablets. Okay, the application that runs on these devices, that comes under mobile application software. So this includes any mobile experience enhancing application or any games like Candy Crush, you can say, or any kind of wallpaper app. Okay, so all this, you can say, the application that serves you on your mobile device can comes under this mobile applications. And web application or web software that we already know that are those that would run on the browser and provides its desired functionalities. Okay, so that we know. Now, apart from this software, as I told you earlier, that there are many different kinds of software. And another one is, you can say, the real world software. Real world softwares, you can say, are those that monitor and control the activities that are happening in the real world, in the real time. That means these are those softwares like, you can say, weather forecasting, like satellite launch software, which control, monitor and analyze the real world events. Okay, as and when they occur. So you can say these are the different kinds of software. And apart from this also, there would be many others, but these are the important ones. Now the next topic is software engineering technology, software engineering as a layer technology, but that we will see in the next class. Okay.